Hey, what's up guys? I hope everybody's well and let's continue with our basic Rhino training. In the previous videos we looked into points, lines, arcs, polylines and so on. Basically all tools with which you can create lines. And the next step, which is very important to actually understand 3D modeling, is to how to modify these lines. So this video and following videos will be all about the curve tools and how to modify curves. I will also include the Grasshopper version of each of the tools if applicable. So if there's a tool for it or if there's a method for it which can be explained in a simple way in Grasshopper, I will also cover that. So let's dive right in. Again, you can see the tools we used before are all here. 1, 2, 3, 4, 5, 6, 7, 8, 9. These tools we looked at. And then we have the next tool is called fillet curves. But actually when you click on the triangle, you see that there are much more tools in there. And it's not just about filleting, it's way more. Instead of having this tool open like that, we can actually also go in here. This is basically a copy of these tools. So the curve tools are, so you're either in the standard tools tool set or in the curve tools. And so we don't need this tool panel. So we can actually use this here on the top, which is exactly the same. And then what it does, it adds here all the curve tools which just talked in the previous videos. So all the curve tools to create curves are actually here on the side. Right at the beginning on that side, we actually have a few other tools which we need to discuss first. They are also in the standard toolbar. So one is join, one is explode, the other one is move. So if we go back here, it's move, join, explode, and there are two other ones, sorry, trim and split. So these are the basic modifying tools. So moving stuff is easy. Let's just create a circle. And there is the gumball, of course. With that you can move stuff. And with this you can move it freely. It has its drawbacks. You know, this is really for moving stuff freely around. You can always use also the numbers to type a number, specific distance you want to move something. The traditional way to move things in Rhino is just taking the using the move tool. But there's another way. Actually, you can just grab things. And now I turn off my gumball. I turn off also auto and object snap, and you see that you can. Oh, that's not what I want. So I can use move. I can just take something and move it around. If I want to be more precise, because I want to move an object from a certain point to another point, then you can use the move tool. And for example, I want to place, let's turn this on again, the object snap. I want to place the circle center, so I snap the circle center. I want to place that to the origin of the plan. Then I just grab it. I could then move it around, could turn on my grid, or I just write the coordinates. M for move, and you move it. You might notice that there's a triangle here on the move, and if I open that you get another big toolbar with a lot of stuff. We will not look at that in this video. The only thing maybe copy like you do in, I don't know, Word or Illustrator or Photoshop, but that doesn't work like that. Yeah, now it crashed. No, it did not. So I copied. I can copy one circle with Ctrl C and Ctrl V and paste it. It takes very long. It's my computer is very old. Then you have two of these curves. But that's not how you copy in Rhino. In Rhino you actually copy with CO. That's what you do. That's how you copy. And now let's check trim and split. So trim is if you trim something away from an object. That can be, that doesn't have to be a line, that can be a surface. It's either a line or a curve or a surface or a set of things. So as you can see, there's this command, it's called trim. There's also an untrim, but we will not touch that at the moment. But trim is, yeah, you will use trim all the time when you draw in plan. So if you click here, trim, then it basically asks you to select a cutting object. And this can be, doesn't have to be a line. You can select this object and then trim, like this. Kind of deletes everything which is on a certain side of that line. Even though it was already cut, I could also then trim it here. Still means trim. But it also works with sets of objects. So if I have, for example, I can choose this and this circle and then cut the other circle. That's also possible. You can also trim within the same set, and now I use the shortcut. I just write TR and select the whole set, and then I can trim out of that set. No. That's another way to trim. Remember that the fastest way is always to use the shortcuts. So trim, finish. That's how it should be. You can also, you don't have to click on the line you want to trim. You can also select select more lines. So it's also possible to do this. Trim, and then select the line from left to right. Splitting is similar, but it retains the object. So it just splits an object wherever you want. So I can split this object with these, for example. So if I click here, split, select the object to split. So I want to split this object, and I want to split it with, then I need to press enter, and then I can select the cutting objects. In that case, it's these. So that will split my object in these segments here. Another very good tool, a very useful tool is split at a point. So for example, you have this and I want to split it on a certain point. In the past, what I did was drawing a line here and then say split, object to split, and then selecting the line. That's one way, but much faster way is actually to use the subcommand. When you type split, you can actually see here, either you type P or you actually can also click there. I haven't mentioned it before, but you can also click here. If you are a clicker, then you can click here. I like to press P, and then you can choose a point on your curve, enter, and that splits your curve as well. That's much faster, and I should use it way more often, but sometimes I just forget. I also forgot to mention that there's another very interesting trimming option. If you trim lines, especially, you have something like this, and you want to cut this line in the extension of that line. Then of course what you would do is like extend, you would first change that line, and then you would trim, TR, select cutting line, and then do this. Another actually much faster way, and especially if lines not always overlap, that's the most annoying thing. If it appears as if this line is almost there, so that it can happen in some plans where you actually think they're touching but they don't, then you can actually use use this extend cutting lines. Right, then you can actually select the cutting object and it still cuts even though these lines don't touch. Yeah, and then of course that also works with a whole set of curves. So I could, for example, do this. Trim. Then it was cutting everything which is actually overlapping from the extension of this curve or this line was cut away. Not these ones because they are actually stopping here before that extension. Yeah, I could then do this. Interestingly, it hasn't cut these because these are all like small separate arcs. But yeah, it's possible. Yeah, so if you have big drawing sets where you need to cut out something, then you can use the trim function. It's very useful. It also works with surfaces, of course. So the other two tools are join and explode. I'll hide these here so you can see how that works. And again, of course, it works with a set of curves or just with two curves. That doesn't matter. So with join, I can just type join, J for join, and then select the curves you want to join. And if the program recognizes that the result will be a closed curve, it will stop the command. But what it keeps here, so you can see that actually it's not this perfect circle anymore. There are two more control points in here. And now if I explode that whole thing, then it's back to these, to what I trimmed first or split it first. So that's important to remember, that it's not repairing it if you join things. There are other commands to actually fix that. Okay, for moving things around in Grasshopper, I created this grid of circles, tries to move them, each of them randomly in plan view. So what we need is the curve container, in that we can bring all the curves into Grasshopper by just set multiple curves, and then we just need the tool move. That would be under transform. There's the you can find all the other tools as well. So what do we need here is the geometry we want to move are the curves, so they turn green because now when I touch that it's green. I want to actually not see the original here in Rhino, so just hide them. So I only see the Grasshopper result, and I will also stop the preview for these curves here. And then we want to move them, and you see that here's you can either put a vector or you can put coordinates. I think it's easier to show it actually. So what I'm gonna do instead of, well, I can actually do this. So I can provide a coordinates here. So I could either provide a list like this. So I could do this. You see that they moved, and 10, 20, 0 means 10 in X direction, 20 in Y direction, and 0 in Z direction. You could also set something for 0. So that's possible. You could do this, or you could do it randomly. The question is how useful that is, but I think it's useful in terms of learning the software. You go into vector and we can construct a new coordinate. It says construct a point, but it's also a coordinate. Or let's create a vector. Maybe that's easier. construct, sorry. So because it asks for a vector, but it wouldn't matter. So in order to get random numbers here, well, I mean, first of all, you could of course put sliders here. That's also possible. So you could set the number. And put this into here. Maybe it's good to actually see that in 3D. And then shift these. Basically you shift all of them in the same directions. You use one vector for all of these curves. Another way is if you want to do it that randomly, then you would, for example, use the random function. So we know that we have 100 circles. So I could either measure that. Let's do that. This is much more nicer. We measure the list length, which is, it measures how many items are actually in here, and it gives you the number, and that we put in here. So because we want to have 100 random numbers, right? So this is the number on how many items, how many random numbers we want, and you can see here all the different numbers. 99. So it always starts counting from 0. That's why we have from 0 to 99, 100 items. So we have this, but now all these numbers are between 0 and 1. We might not want that. So we need to set a different range, and the range can be set here. So you can actually see here that the range is set to from 0 to 1, but I could also set it to, let's say, minus 100, 100. So now I have 100 values between a minus 100 and plus 100. So if we put this here now, it actually moves stuff, but it's only moved it in the Z direction. That's not what we want. Could also do this, but then it's kind of moves in a weird way because we're using the same numbers for Z, Y, and X, but we want to shuffle these. Can either take this, copy this, and then use a different seed value. And that was not good because it should be a number. So that is possible. Or what we can also do is, instead of it's actually a bit more tidy, but it's different also, is to set the jitter. So it just takes the values which you already created here and shuffles them. And you could then also do this, shuffle them twice. Maybe that's not nice because that's now, let's do it like this. Or we don't shuffle the C value. That's also possible. So that's, I mean, that goes, of course, way far away from just using the move function, but it's just fun to play around. You can also control the range with sliders, of course. So you could actually use a function called range. Actually, I think we can only use, just need to use the domain here. This one, construct domain. That's what we want. So we could have -50 as a minimum, and here maximum, and 0 maybe. And then this one could be the opposite. Like this. Yeah, that's moving things around. Okay. Now let's try to split. We actually split stuff. This is just the beginning of way more complex scripts. Just to show you that all the things you do in Rhino are actually also possible in Grasshopper. Again, so this is just very like a basic approach for now. I want to split all these circles with one line, then I can use the tool here. Here it is. You basically split. So I have this stored in here, and you choose one set which you split with another set. So that could be, of course, could be not just one line, it could be 2 lines or 3 lines. Let's do it like this, so it actually has a bit more purpose. So now I have 3 lines in here, and I want to split these 3 lines with my circles. Then that doesn't work. Good to know. So here you can only load one curve and one other set of curves. So that is possible. Interesting. I wonder if I flatten these and these. Doesn't make a difference. Okay, so I can, good to know, I actually, see, I learned something new. Can only use one curve, but you can move them around and you get all these intersection points. Another way to trim or to intersect curves, because it's actually, you don't trim really things yet, is this one. No, sorry, this is intersection of a curve itself. That's also possible, or multiple curves. So this just takes the whole set of curves and marks all the intersections. So that could become very useful actually. So it gives you the parameter, the distance on the curve from the origin of the curve. So although this is a circle, they still have a start and an end point. And these TA and TB are actually marking these positions. It's a bit abstract, but yeah, so that's why. Let's leave it here, and we will come back to that at some point. So we leave it here, and next time we look into fillets. Very exciting. So I think next time we can hopefully cover all these, but I want to keep the Grasshopper component within, because it helps us to actually learn the Grasshopper at the same time, because it's important. Everybody knows Grasshopper nowadays, especially the kids coming from uni. They know it. Okay, see you next time.